the guys are already calculated the V value. It may nearly to come 29.6 meter per seconds, nearly to 30. Okay, so that is already there. Why? Because here we are missing the some terms. Those are the squares. So squares are missing in earlier problem. So now we will make the calculation. When we are putting the squares and okay, calculate the particular equation. So then simply to get the our V value nearly to comes 29.6 meter per seconds. So this is the last class. Okay. And now today topic is okay, effect of two-wheeler vehicle. Okay, stability of two-wheeler vehicle. Effect of stability of the two-wheeler vehicle. So that is okay, similar to this one, but the smallest amendment is there. All of you observe that. Roll number 363, please turn off your cam. Okay, now all of you observe that. So now the today topic is stability of two-wheel drive moving in a curved path. So all of you observe that. So figures, all of you observe the three figures are there, figure A, figure B, figure C. So here the condition is, okay, two-wheeler vehicle, just we will consider the two-wheeler vehicle, the two-wheeler vehicle will take the turn. So the turn is right turn here. So we are taking to be the condition of right turning. So here, okay, this is also considered as okay, front wheel and rear wheel, and the engine is there. And now we will take the right turn. So here all of you observe that one of the important term is there, that is the angle of heel. So angle of heel means, all of you observe that the wheel will takes to the inclination with the vertical axis. It's known as the angle of heel. So all of you observe the figure B. So when we are taking to be right turn of the two-wheeler vehicle, so then we get the some inclination of the our front wheel. So that wheel is also getting to the inclination with the vertical axis, not only our road surface, vertical axis. So that means while the vehicle is moving on a straight path, okay, there is no angle, particularly to the theta, angle of heel value. So but when we are taking to be the turning, the okay, it makes the some inclination, that is the theta inclination. All of you observe that. And our particular wheel will also get the okay, some self weight is there, W. Actually this is considered as the total weight, W is there. And FC means centrifugal force. FC is the centrifugal force. And center of gravity is also there, that is the H value is the center of gravity. And here all of you observe that when we take the inclination theta, so then the value will comes H value, okay, to the horizontally, okay, when we consider as the this vertical portion of our okay, center of gravity value is the H cos theta. H is replacing with H cos theta. Vertical component value is the H cos theta. Okay. And now smallest amendment is there between the before derivation to the this derivation. That is the, here OA is there. OA. This is the axis of spin. Actually, we will take the axis of spin is the OA. So that is the wheel will get the angular velocity of omega. When we'll take the horizontal component, that is the our horizontal component value is omega cos theta. Horizontal component value is how much? Omega cos theta. So here the where we are having the omega in earlier derivation, that places is replaced with the omega cos theta. That place is replaced with omega cos theta. And where we are having the H, that place is replacing with H cos theta. That is the smallest amendment between the two-wheeler vehicle to four-wheeler vehicle. Why we are replacing with the particular value? Why? Because we are adding with the inclination, angle of heel here, angle of heel. So while we take the right turn, so it makes the some inclination with the vertical axis, that is the theta is there. All of you observe the my okay, my mouse indentation. So all of you observe here particular figure. So when we observe that, so weight point of view, W is there, W acting on the towards okay, bottom side. So that is there, and the centrifugal force is also there. Centrifugal force opposite to the vehicle direction. Okay, so that is the FC is there, and H is there, center of gravity. So while we take the turnings, that value, that vertical component value is comes H cos theta. And now coming to the third figure C point of view, we'll observe that omega is replacing with the term that is the omega cos theta. So that horizontal component, the horizontal force is the omega cos theta here. So that is there. And OX is there, OY is there, OZ is there. OX means what is the term indicate? What is the term indentation? Oh, okay, indication of the OX. Nearly to say that, simply to say that axis of spin. And OY, axis of precision, and OZ, axis of active gyroscopic couple. So those are there. So here, okay. So why we are replacing with the H is replacing with H cos theta, and omega is replacing with omega cos theta. Why? Because it is adding with the term of angle of heel here, angle of heel. So here the two-wheel vehicle is also moving with the right turn in our figure. So all of you observe that. So now here in this okay, in this also follows the okay, two types of effects are there. Our two-wheeler vehicles, those are the effect of gyroscopic couple and effect of the centrifugal couple. Okay, so now we'll find out the okay. Now we will find out the effect of gyroscopic couple. So when we are going to find out the gyroscopic couple effect, so first we will write our angular velocity of the wheel. So angular velocity of the wheel is there. So that is the omega suffix w. Generally calling okay, generally representing with the term of omega suffix w. So that is omega cos theta. Why? Because the horizontal force value here already replaced with that horizontal component is how much? Omega cos theta. So omega suffix w means omega cos theta. Again omega suffix omega value is how much? So that is replacing with the term of V by small r, V by small r. And again, okay, V by small r. Now going to write the angular velocity of precision, omega suffix p. So omega suffix p means, what is the omega suffix p? So here all of you observe that. Omega suffix p means, okay, V by capital R. What is the formula? V by capital R. V by capital R. So all of you observe that. So V by capital R and V by small r cos theta. So now we are going to write our gyroscopic couple. So gyroscopic couple due to the two wheels. So here number of wheels are the two. So then gyroscopic couple due to the wheels are 2 into I suffix w and omega suffix w and omega suffix p. So that is the formula is there. 2 into two wheels are there. So that's why I are multiplying with the 2. 2 into I suffix w, omega suffix w, omega suffix p. So now gyroscopic couple due to engine parts, due to engine. So that is the I suffix e, omega suffix e and omega suffix p. So now net gyroscopic couple. So net gyroscopic couple. So net gyroscopic couple means sum of the gyroscopic couple due to the wheels and sum of the gyroscopic couple due to the engine parts. So when we write the particular term that is represented with the net gyroscopic couple C1, so equals to 2 into I suffix w and omega suffix w, omega suffix p plus or minus I suffix e into omega suffix e is replacing with that omega suffix e is replacing with the term, that is the G into omega suffix W. Why? Why? Because already know the, okay, gear ratio G equals to omega suffix E by omega suffix P. So omega suffix E is replacing with G into omega suffix W. So that's why you are writing here, and omega suffix P. So when we write that, and again we will, okay, and again we will also replacing with the terms, that is the omega suffix W means V by small r cos theta, and omega suffix P means V by capital R. So again all of you observe that here one of the term is missing, that is the square. Square is missing. Okay, so V into V means V square here. Okay, omega suffix W means V by R small r cos theta. Omega suffix P means V by capital R. V into V is the V square by capital R into small r suffix W cos theta, into remaining terms are, when we taken out the total term, okay, so the remaining terms are 2 into I suffix W plus or minus G I suffix E. Okay, in our four-wheel vehicle, just this place, two-wheelers is replacing with 4, and cos theta is not there, but here cos theta is also there. Okay, cos theta is also there. So that is the effect of gyroscopic couple. The lateral entry 36, sorry, lateral entry 329. Please turn off your mic. Okay, so our gyroscopic effect of gyroscopic couple is C1 equals to V square by capital R into small r suffix W into 2 into I suffix W plus or minus G into I suffix E cos theta. Okay, this is the effect of gyroscopic couple. Now going to, okay, now going to make that effect of centrifugal couple. Now we are going to calculate the effect of centrifugal couple. So all of you observe that. So before going to write the centrifugal couple, so first we will write the centrifugal force value, that is the mv square by r. Okay, this is already known the value, mv square by capital R. And now going to write the couple. So centrifugal couple equals to, so this is a, okay, the symbol represented with C2, that is the force into distance. The distance value is how much? So mv square by capital R into h cos theta. H is replacing with h cos theta. Okay, h is replacing with perpendicular distance, that is the h cos theta. So now total overturning couple. Okay, total couple. So total overturning, when we take the overturning, so then that effect, how much of effect is there total by the help of our overturning couple. So that is sum of the our gyroscopic couple effect and centrifugal couple effect. That is the our V by, that is all of you observe that V square by capital R and small r suffix W 2 I suffix W plus or minus G I suffix E cos theta plus mv square by capital R h cos theta. This is the overturning couple. When they asked total overturning couple, then the sum of the, okay, effect of gyroscopic couple and effect of the centrifugal couples. And then how to be balanced? What is the balancing couple is there? So that is a balancing couple is also written that. So overturning couple is also equals to, okay, balancing couple. So then all of you observe that balancing couple means mgh sin theta. Balancing couple is mgh sin theta. And therefore here, okay, this one, this equation and this equation is are equal. When we take the equal, so this is the overturning couple and this is the balancing couple. So then it will always makes that V square by capital R into small r suffix W 2 into I suffix W plus or minus G I suffix E cos theta plus mv square by R h cos theta equals to mgh sin theta. This is the main condition. Okay, this is the our main condition. So that means when we take the sometimes overturnings, that time, okay, is also able to withstand the our vehicle. How it will be withstand of our vehicle by the help of balancing couple. Okay, by the help of balancing couple. That balancing couple value is how much? mgh sin theta. Okay, mgh sin theta. So you are observing that. You will observe here particular place. Okay. So balancing couple written here. So that is the our mgh sin theta. That is the our in our overturning point of view, they may take the particular values. Okay, vertical component values at the figure B. And balancing couple point of view, they may take okay, horizontal component mgh sin theta. So that is the okay, that is the small element, that is the small change is there. Okay, please turn off your cam number 351. Number 351, please turn off your cam. Hello. Please, okay, unmute your mics and raise the queries in our derivation part. In our derivation part. Roll number 351. Just unmute your mic only. Please turn off your cam. Okay. Please raise the queries. Number 302 and 376. Please respond.
Yes, sir.
సార్ జీసీ డ్యూ టు ఇంజిన్ లో ఉంది కదా, అక్కడ ఒమేగా సఫిక్స్ ని నెక్స్ట్ స్టెప్ లో జీ ఇంటూ ఒమేగా డబ్ల్యూగా ఎలా రాశారు?
ఎలా రాస్తాం అంతేనా?
ఎస్ సార్.
So already I said the formula of gear ratio. Gear ratio equals to omega suffix e by omega suffix w. Gear ratio formula is omega suffix e by omega suffix w. Okay, angular velocity of the engine to the angular velocity of the wheel.
Okay, sir.
Okay, that is the already formula is there.
Okay, sir.
So that's why omega suffix e means g into omega suffix w. So that's why replacing it always.
Thank you, sir.
And any other doubts? And all of you observe that smallest amendment okay, between the four-wheel vehicle and two-wheeler vehicle, that is the here omega is replacing with omega cos theta. Omega suffix w is replacing with omega cos theta, and h is replacing with h cos theta. Why? Because here we are having the angle of heel while we take the turnings. So that okay, that is the small amendment is there. So that amendment will make that in our entire net gyroscopic couple is adding, okay, multiplying with the term of cos theta, and our centrifugal couple point of view cos theta multiplying with cos theta, and balancing couple point of view multiplied with sin theta, mgh sin theta. So that is there, balancing couple. So when we write the balancing couple, then simply to okay, equating the this equation and this equation, total overturning equation and our couple value. So that is there. Okay, is it understand? Please respond.
Yes, sir.
Okay, now we are
Yes,
going
sir.
to
Yes, sir.
now we are going to discuss the okay problem belong with the two-wheeler vehicle. So all of you observe that. Number 376.
Sir.
Okay, please take the attendance.
Okay, sir.
Okay. Now all of you observe the problem belongs to the two-wheeler vehicle. So all of you observe that each road wheel of a motorcycle of the 600 mm diameter, wheel dia is the 600 mm, and moment of inertia wheel 1.1 kg meter square, and the motorcycle and the rider weight okay 20 mm above the road level, and moment of inertia of the engine point of view 0.18 kg meter square, and gear ratio 4.5, and find the angle of heel necessary when the motorcycle is taking a turn of 35-meter radius. Okay, r capital R value is the 35 meters, and the speed of the vehicle is 72 kmph. So those are the given data is there. Now first we will write the given data. So that is the small r sub w value is the 300 mm, so that is also equals to 0.3 meter, and I suffix w is 1.1, and I suffix e is the 0. Okay, 18, and capital R 35 meters, and theta value is the unknown, that is the determining value, and mass of the rider plus vehicle 220 kg, and h value is the so that is the our mph. So omega suffix p equals to v by r, that is the formula already known that. So now here what is the determining value is there? Theta. All of you is there. So theta means how we are calculating the theta value when we are taking the particular formula, that is the our v square by, okay, so all of you observe that. So v square by, here again we are missing the term, so that is the our so that is the v square by what we write the particular formula. Okay, v square by capital R into small r suffix w 2i suffix w plus GAE cos theta plus mv square by r into h cos theta equals to mgh sin theta. What is the final formula is there? Okay, in our two-wheeler vehicle. So that is the value is there. So then all of you observe that. So that is all of you observe that v square by capital R small r suffix w 2i suffix w plus GIE cos theta plus mv square by r into h cos theta equals to mgh sin theta. In this we may also okay taken out from the v by only capital R, v by capital R, v by capital R. So now, so that is the value is there. Okay, v by capital R into now the remaining term is there, that is the our value is v by rw into 2i suffix w plus GIE plus mvh into cos theta, that equals to mgh sin theta. So now all of you observe that. Okay, so v by r means capital V value is the 20 and 30, capital R value is the 35 meters. So and again here all of you observe that v by capital R and 1 by r suffix w, r suffix w is okay 0.3, and iw is there. Just you will substitute the known values, all the known values. So when we substituted that
VBR లోని VBR కామన్ లేదు సార్.
అరే అరకుండా మామూలుగా అడగరా ఏంటి
okay
అడుగుతావు?
hello
VBR ఉంది కదా, V స్క్వేర్ బై ఆర్,
hmm.
V స్క్వేర్ బై ఆర్ లో VBR కామన్ తీసాం కదా, ఇంకా రిమైనింగ్ V ఉంటది కదా.
అదిగో ఇక్కడ చూడండి, ఒకసారి చూడండి, అదే మిస్ అయింది, కొంత టర్మ్ మిస్ అయింది ఇక్కడ. ఓకేనా?
Yes sir, yes sir.
V ఉండాలి.
అబ్జర్వ్ దట్. V by R, and what are the known values? Okay. So V place V అనేది ఎక్కడైతే మిస్ అయినా ఆ V ని V సబ్స్టిట్యూట్ చేయండి, and then okay, all the known values are substituting in our entire equation. So then the unknowns are only thetas. So cos theta, okay, left side here cos theta is coming and right side are sin thetas. Okay, sin thetas are there, and now cos sin theta by cos theta, when we, okay, numerical values are there, that is multiplying with cos theta and multiplied with the sin thetas. Just we will take out the, okay, sin theta by cos theta numerical value, then simply to come some value is there, so then nearly to get, okay, theta value. So just all of you substituted the known values in our problem, known values. Okay, the maybe it will varies, the answer is varying. Okay, you will calculate the value. Why? Because when I made the particular problem, I missed the particular term, that is the V by R suffix R, capital R into small r suffix W, but actually the formula is V square by V square. Okay, so that is the thing is there, V square. Squares are missing while we made the, okay, that time. Okay, someone will say the answer. So the roll number is I will call you, okay, and tell me the answer. Lateral entry number 325, Balu, please respond and tell me the answer. Lateral entry Balu 325, lateral entry 325, please tell me the answer.
Made sir LA 325.
325 is not available.
Model.
Okay, but he is in participant list.
Maybe regular sir. Regular sir.
Regular, is it regular? Huh?
Ah sir. 18 series regular.
Wait a minute. Yes, regular 325. Balu, please tell me the answer. What we made the in our problem, that is the wrong answer. Why? Because we are not consideration of the V square. Okay. Okay, and all of you copy the matter. It is very important. Okay.